Well, hi everybody. All right, we are kind of coming to the apex of our work on polynomials. So we are right now at the fundamental theorem of algebra, and it states, and it was Carl Friedrich Gauss, German mathematician, one of the smartest people ever to walk the planet, is the one who came up with this when algebra was still kind of in its early development stages here. But if f of x is a polynomial of degree n, where n is greater than 0, if it's a polynomial, n is going to be greater than 0, then f has at least one 0 in the complex number system. Okay? And we'll talk about that. And off of that, here's an offshoot, is the linear factorization theorem. So we're going to use some of this to factor polynomials and such. If f of x is a polynomial of degree n, then f of x has exactly n linear factors. And we have this kind of compressed way of writing it. F of x equals a sub n times x minus c1 times x minus c2 times and so on, x, where c1, c2, and so on to n, which is the degree of the polynomial, are all complex numbers. Now I added just a little bit to that. So the multiplicities of all of the zeros of a degree n polynomial add up to n. You know how we talked about multiplicities. If you add all of the multiplicities of all the zeros of a polynomial, you will get n. All right, well, let's take a look at example 1 here. It says determine the number of zeros of the polynomial function f of x equals x to the 4th minus 1. All right, well, the degree of this polynomial is 4. So according to this, we should be looking for 4 zeros. All right, well, let's just take a look at this real quick. If I have x to the 4th minus 1, and I want to find all the zeros, I'll set it equal to 0. And if you could add 1 to both sides and then take the 4th root, but you're only going to find 1 0 doing that. So I'm going to have us, let's factor this. And I'm going to use difference of squares. And the square root of x to the 4th is x squared. So we'll go x squared plus 1 times x squared minus 1. And if I factor some more, I've got x squared plus 1. And this can factor difference of squares again, whoops, times x minus 1 equals 0. So I'm going to solve. I can't factor that one. I'll go x squared plus 1 equals 0, and I'm going to solve that. I'm going to subtract 1 from both sides, get x squared equals negative 1. I'm going to then take the square root. You know, when we take the square root, we've got to go positive and negative. There's a positive square root and a negative square root. So x is equal to, and if you recall, the square root of negative 1 is I. And then I have this factor. I have x plus 1 equals 0, which means x is negative 1. And I have x minus 1 equals 0, which means x equals 1. So my zeros that I'm seeing here are I, negative I, from this one, negative 1, that's a 0, and positive 1. So we have 4 zeros for this 4th degree polynomial. Okay. Now the next thing I want to work on with you here is we're going to be looking for zeros. Some of them will be rational zeros. And we're applying the fundamental theorem of algebra as we go through here. We just know how many zeros we're going to be working with. And some zeros are rational, some are irrational, some are complex, means they have an imaginary part. But we're talking about real rational zeros right now. And we have this little test here. The possible rational zeros of a polynomial with integer coefficients would have to satisfy the following. The factors of the constant term, that last term, like this -4 here, over the factors of the lead coefficient. If it's a possible rational zero, then it could be the fraction, the factors of the constant term over the factors of the lead coefficient. All right, it was a little cumbersome to say. Let me just show you what I mean. If we're going to do this test, we've got the rational zeros are going to equal the factors, and I should say possibles. You know, some of these won't be zeros. Factors of, for this problem, -4, that's the constant, over the factors of 1. Well, the factors of -4, that would be +1, -1, +2, -2, and +4, -4. The factors of 1, which is the lead coefficient, would be positive or -1. You got to consider the positives and the negatives here. So, our possible rational zeros. Okay, if you're dividing by positive or -1, you're going to have positive or -1 here. Positive -2 would be just what we have in there in the numerator. We have 6 possibilities to be rational zeros of this polynomial, x cubed plus 2x squared plus 6x minus 4. Now the job is to find a way of doing it. And the best way I could tell you is, let's just try, we're going to use synthetic division. Let's see if 1 is a 0. If 1 is a 0, then if I use synthetic division, I'll have a 0 at here. I'll find that f of 1 is equal to 0. And that's what it means to be a 0. Okay. I'm going to use synthetic substitution to do that. 1 times 1 is 1. 2 plus 1 is 3. 1 times 3 is 3. 6 plus 3 is 9. 1 times 9 is 9. -4 and 9 is 5, which is not equal to 0. So 1 is not a 0. Well, I'm just going to go in order here. Let's see if -1 is a 0. Use the 1, 2, 6, and -4. Bring down the 1. -1 times 1 is -1. 2 plus -1 is 1. -1 times 1 is -1. 6 plus -1 is 5. -1 times 5 is -5. And -4 and -5 make -9. That's not equal to 0. So -1 is out. It's not a rational 0. Well, let me try 2. 1, 2, 6, -4. Bring down the 1. 2 times 1 is 2. 2 times 2 is 4. 4 times 2 is 8. 6 and 8 is 14. 2 times 14 is 28. This isn't going to work either, is it? 24 is not equal to 0. 2 is not a 0. So half of them, we've tried half of them so far, and none of them, those are zeros yet. Well, let me do this. Negative 2, let's put 1, 2, 6, and negative 4 down. Negative 2 times 1, that's negative 2. 2 and negative 2 make 0. Negative 2 times 0 is 0. 6 plus 0 is 6. Negative 2 times 6 is negative 12. Negative 4 and negative 12 is negative 16, which once again is not equal to 0. All right. We are 0 for 4. We've got 2 more possibilities. Let's try 4. 1, 2, 6, and negative 4. Bring down the 1. 4 times 1 is 4. 2 plus 4 is 6. 4 times 6 is 24. Not looking promising. 6 and 24 is 30. 4 times 30 is 120. Negative 4 plus 120 is 116, which once again is not equal to 0. 4 is out. If it has a rational 0, it's got to be negative 4. 1, 2, 6, and negative 4. We've exhausted all the other possibilities. Negative 4 times 1 is negative 4. 2 plus negative 4 is negative 2. Negative 4 times negative 2 is 8. 6 plus 8 is 14. Negative 4 times 14 is negative 56. This is negative 60. Okay. That's not equal to 0. We can conclude f of x, which is defined up here as x cubed plus 2x squared plus 6x minus 4, has no possible, well, not possible, has no rational zeros. We tried every possibility. If it has a rational 0, it's going to be one of these 6, and it doesn't have it. So that is out. All right. Let's try one more example here. Find the rational zeros of this function. F of x now is x to the third minus 15x squared plus 75x minus 125. Sometimes this is not 1. I do have an example where it's 1. In those cases, we'd have to do a little more, but the possibilities need to be discussed. Now, 125, think of all the factors. 1 goes into 125. 5 does. 5 times 25. And then I think 125. So I think the positives and the negatives that you've got to consider here. So negative 1, positive 1, plus or minus 5, plus or minus 25, and plus or minus 125. And the coefficient, the lead coefficient is 1 over plus or minus 1, so we don't have to do anything special there. So we're going to try positive 1, negative 1, positive 5, negative. We're going to see which one of these might work. So let's just start with 1 and see if 1 is a 0. 1, negative 15, 75, negative 125. Again, I'm using synthetic substitution. You could just plug 1 in and see if you get 0. I'm going to do it this way, though, because it's a nice little tool we have. All right, 1 times 1 is 1. Negative 15 plus 1 is negative 14. 1 times negative 14 is negative 14. 75 and negative 14 is 61. 1 times 61 is 61. This is not equal to 0. All right, negative 1, it's your turn. 1, negative 15, 75, negative 125. Bring down the 1. Negative 1 times 1 is negative 1. That is negative 16. Negative 16 times negative 1 is positive 16. 75 and 16, I think that's 91. Negative 125 and negative 91 is not equal to 0. It is not 0. All right, 5, you're up. 1, negative 15, 75, negative 125. Bring down the 1. 5 times 1 is 5. Negative 15 plus 5 is negative 10. 5 times negative 10 is negative 50. Uh-oh. 75 plus negative 50 is 25. 5 times 25 is 125. That is 0. So, one of the zeros is 5. I'm going to do something here, because also if we think about it, if we have divided this, if we divide this by x minus 5, 5 is one of the zeros. Okay? So we have x squared minus 10x plus 25. That's the answer if we divide by x minus 5. I think, rather than just trying these all over again, that if I were to factor this, it appears to me that that is x minus 5 times x minus 5. So, and we've already done x minus 5 earlier. That's not part of this part. So it appears to me that 5 will be the only 0. So you set the factor you get equal to 0. You get x is 5. And this already took care of it. We knew it was 0. And if we factor this some more, all the factors are x minus 5 times x minus 5 times x minus 5. So 5 has a multiplicity of 3 in this, which makes 5 the lone rational 0, and it's the only 0 period. All right, that is all for now.